define density. Density is mass per unit volume. The question asks you to calculate the absolute uncertainty in X. Now the absolute uncertainty in X, which is delta X, should be equal to percentage error in X times the actual value. So the percentage error in X is 5%. So 5% of the actual value, which is 4, and the answer that you get is plus minus 0.2 centimeters. That is the absolute uncertainty in X. The next part says determine the percentage uncertainty in the density. So they've given you the equation for mass, density, and volume. You can clearly see here. Let's make density the subject first. जिस भी चीज़ में uncertainty निकालनी हो उसको पहले subject बनाया करें. So density will be 3m over hx squared, right? 3m over hx squared. Now, percentage uncertainty in the density would be equal to percentage m plus percentage h plus 2 percentage x. So percentage uncertainty in the density would be equal to percentage m, that's 2%. Here it's given percentage h, that's 4%. And percentage x was 5%, so 2 times 5%. So percentage uncertainty in the density should be 10 plus 6, that is 16%. And the last part is pretty simple. They're asking you to calculate the average pressure. Pressure is given by force over area. So force is mg, which is the weight. That is 19.5 grams. Convert the grams to kgs and do not forget to convert that into newtons. Divided by the area. Now, it had a square base, right? And the length of one side was x. So if it's a square, it'll be 4 into 4 into 10 raised to the power minus 4. Why? Because centimeter to meters, for this, if you take them together, you can simply say 4 into 10 to the power minus 4. Or you could just do 4 into 10 to the minus 2 into 4 into 10 to the minus 2. Whatever suits you, please do that. And your answer to this should be 120 pascals. You actually end up getting 119.55. But remember, all of your answers are always given to 2 to 3 significant figures. So you just write 120, because even if you try writing to 3SF, you'll have to look at this. It'll round it off to 120. So as a flat rule, remember, just give your answers to 2 to 3SF and you'll never go wrong, inshallah. So in this question, the first thing is, what is moment? So moment of a force is defined as the product of F into D. And as you know, you can just simply define the symbols. F is the force applied and D is the perpendicular distance from the pivot. Now part B is interesting because it says a rigid rod is pivoted about a point 6.2 centimeters from the center of a pan. So 6.2 centimeters from the center of the pan, you have a pivot. And the object being measured is placed on the center of this pan. So whatever you want to measure, you put on this pan. A spring is attached to the rod 1.8 centimeters from the pivot, as you can see. And at the other end to a fixed point. So the spring is attached to a fixed point. The spring obeys Hooke's law over the full range of operation of this balance. A pointer on the other side of the pivot, this is the pointer, is set against a millimeter scale, which is a distance 52.6 centimeters from the pivot. So pivot, say distance is 52.6 centimeters of this scale. Now, when the system is in equilibrium, with no mass on the pan, the rod is horizontal and the pointer indicates a reading of 86 mm. So they're basically trying to tell you that the point where you are right now, this position indicates a reading of 86 mm. Now what you do is you place an object like they're telling you over here. And when you place this object, what's going to happen? This side is going to tilt down and this pointer is going to move upwards because there is an imbalance on both sides. And the question is also telling you the same thing, that when this pointer moves, it moves to indicate a reading of 123 mm. So when this thing moves up, the pointer it goes to, let's say, this position, and it's indicating a reading of 123 mm. So if you want to visualize it, it's like it was horizontal. Let me indicate it with the hand symbol. It was horizontal like this, but when you placed a weight on this side, it moved like this. So this side is down, this side is up, and it is back in equilibrium as the question is saying. So you are in equilibrium again. So if I may draw a single straight line to show you the movement, you can safely assume that, let's say, this was a straight line representing where you were initially. Now it is something like, for example, this. So this is how you moved. You moved down from one side, which is this side, and you moved up from this side. Okay? And you're again in equilibrium, so you're not moving anymore. And they're passing through a single common point, which is the pivot. Now, part 1 says, show that the increase in the length of the spring is 1.3 mm. Now that's interesting because the spring is going to be pulled downwards because it is on this side. So it's going to be pulled this way. The increase in length would mean this increase in length, where the spring is, not this one. This is where the object is. They're asking you for this increase in length. And now how do we calculate this increase in length? An idea that comes to mind is that if I calculate this angle alpha, it should be equal to this angle alpha because they're alternate angles, aren't they? In those sides के दरम्यान में angle alpha है, उन्हीं दो sides के दरम्यान में side भी angle alpha होना चाहिए. It should be the same angle alpha on both sides. And why am I looking at this increase in length and not this one? Because they're asking for the spring. The spring is connected here. So the movement over here is going to be less as compared to the movement over here because they have the same angle. So यहाँ पे जो delta L होगा और यहाँ पे delta L होगा, वो दोनों delta L's फर्क होंगे. And if the question in your mind is, why are these two different? तो please समझने की कोशिश करो कि angle same है. Now, if angle is the same and I apply tan theta or tan alpha, so tan alpha should be equal to perpendicular over base, right? So अगर मैं कह रहा हूँ कि इसके लिए इस triangle के लिए जो angle है वो और इसके लिए जो triangle इस triangle के लिए जो angle है वो दोनों angle same है because angle तो same है. What does that mean? If the perpendicular is small, then the base will be small. And if the perpendicular is large, the base has to be large. Think about it. I'm saying tan alpha has to be the same. Now, if you consider the bigger triangle, तो इसका perpendicular बड़ा. Naturally, the base is large as well for it. And if you consider the smaller triangle, which is this one, if its perpendicular is smaller, the base has to be smaller so that tan alpha or alpha is the same. So remember that this delta L and this delta L would not be the same. You're concerned about this delta L, which is the extension in the spring because the spring is here. Your spring is going to experience a downward force over here and it's going to extend. Now, how do we find out what is tan alpha? So tan alpha on this side should be equal to tan alpha on this side because angle दोनों तरफ same है. Angle is equal on both sides. So if I consider this triangle over here, tan alpha should be equal to this distance, which is 123 minus 86 divided by 526 because I've converted centimeters to millimeters. So tan alpha turns out to be 37 divided by 526, right? And now let's apply tan alpha to this triangle. The answer should be the same. Now when I apply to this triangle, tan alpha, let me write it here, tan alpha turns out to be equal to delta L, which is the perpendicular, and the base is going to be 1.8 because I'm considering this triangle. Because remember, we're considering the force on the spring and the extension in the spring. So we have to maintain this triangle over here. And the base is 18 millimeters. So divide by 18. So delta L over 18 should be equal to 37 over 526. And when you cross multiply, you should get delta L as 1.266, which is 1.3 mm, and that is the extension in the spring. Now in the next part, they ask you to calculate the moment about the pivot of the weight of the object. So this is your object and this is the weight. They had already given you the mass, so you use W is equals to mg and you multiply it with this distance, 6.2. Just remember to convert centimeters to meters. So moment should be equal to force into distance. The force is m into g into d. Now let's break it down. The mass is 0.472 kg times 9.81 times 6.2 into 10 raised to power minus 2. Do not forget to convert centimeters to meters. And the answer that you get is 0.29 Newton meters. Then use your answer in B2 to determine the increase in the tension in the spring due to the 0.472 kg mass. Now you must understand that the moment on this should be equal to the moment in this, because both of them are moving down in this direction. So moment should be equal to force into distance, and the distance now is 1.8 into 10 raised to power minus 2. And remember that this F is actually the increase in F or the change in F, because this F is what caused this movement of delta L. So the moment on this side is 0.29. So 0.29 is the moment is equals to F into 1.8 into 10 raised to power minus 2. And therefore F, or the increase in F, should be equal to 16 newtons. I would like to mention something here. A lot of you might confuse this as if I've applied the principle of moments. No, I haven't. Dekho, listen to me. This is the rod. This is the pivot. You've put a ball over here, and that ball has caused this rod to move down, right? It caused the rod to go like this. So this entire side went down. So I'm saying that the moment on this side is this. Now, that same moment caused this spring to extend, right? Now, they're asking you what was that force that was created because of that extension. So moment is going to be force in a distance. It's the same moment. इस side पे moment एक ही है, which is 0.29. Because force आप यहाँ पे apply कर रहे हो. This force is causing a force in the spring, which is why the spring is extending. So please do not take this as clockwise moment is equal to anti-clockwise moment, because I'm not comparing this side with this side. I'm comparing two things on the same side. In other words, I'm saying that the moment created by the ball is moment utilized by the spring as well. So moment in the spring would be F into D. The distance of F from the pivot is 1.8 centimeters. Convert that to meters and got the increase in the tension or the increased force in the spring. Use your answers in B1 and your answers in B3 to determine the spring constant. Now you know that the force is 16, or delta F is 16. So delta F should be equal to K times delta L. So K should be 16 over delta L. And I think we proved that in the previous part as 1.3 millimeters. So I could convert that to meters. 1.3 into 10 raised to power minus 3. I could divide that and I'll get the answer 1.2 into 10 raised to power 4 Newton per meter. If your question is, can I leave it in millimeters? Of course you can. You could simply write 16 divided by 1.3 and whatever answer you get, just write Newton per millimeter, okay? State the name of the law that relates force and extension. Well, it's pretty clear. That's Hooke's law. The next part says, what is the spring constant in Newton per meter? Well, you know that this is a force versus extension graph. So the gradient of this graph is going to give you the spring constant. Let's just find out the coordinates of this point. So on the x-axis, I've got 5 centimeters. Do not forget to convert it to meters. So that will be 5 into 10 raised to power minus 2. And the force, if I extend this line this way, well, seems to be right in the middle. So this is 7. The force is 7. Spring constant is F over E. The force is 7 and the extension is 5 into 10 raised to the power minus 2. So you divide 7 by 5 into 10 to the power minus 2 and the value of the spring constant turns out to be 140 Newton per meter. Now you might be wondering, I've written gradient is equal to spring constant. Why did I not find the gradient? I could have found the gradient as well. It would have given me the same answer because the coordinates over here are 5 into 10 raised to the power minus 2, comma 7. And the coordinates over here are 0, 0. So when you do y2 minus y1, which is 7 minus 0, over x2 minus x1, you would get the same answer. Or you could simply use k is equals to f over e. Okay? Now I want you to note something here because in the next part we might be needing it. When the extension in the spring is 4 centimeters, what is the force? Just figure that out, please. The force is going to be 5.6 newtons. Please check it. In the next part, they've also asked you to find out what is the strain energy. Remember, energy is the area under the graph or force extension graph. And if I can shade it for you, it's always the area with the extension axis. So always shade the area with the extension axis. They're saying calculate the energy stored when the extension is 4 centimeters. So I am enjoying the shading, therefore I'm shading it. Well, I should stop. And now let's find out what the force is. Let's find out what the energy is. So the elastic potential energy would be half Fx, which is 1/2 of 4 into 10 raised to the power minus 2. That is the base, this, and the height is obviously 5.6. And when you multiply this, you end up getting the elastic potential energy as 0.11 joules. So as discussed in the previous part, you should know that when the extension is 4 centimeters in the spring, the force in the spring is going to be 5.6 newtons. Now, this force of 5.6 Newton is pulling this block upwards like this. The weight of the block or the cylinder is 6.2 newtons, which is downwards. And the question really is, show that the upthrust acting on the cylinder is 0.6 newtons. So upthrust would be equal to the downward force minus the upward force. Why? Because it is suspended. It is suspended. Upthrust is definitely acting upwards. Upthrust का direction हमेशा ऊपर की तरफ होता है. Upthrust always acts upwards. So you could say that this weight would be equal to upthrust plus 5.6, or you could say upthrust is 6.2 minus 5.6, which is 0.6 newtons. Next, they ask you to calculate what is the pressure difference between the top and the bottom surface. So we'll use the upthrust because upthrust is what causes the pressure difference. Let me write it down. Pressure difference would be equal to the upthrust, which is the force, divided by the area. Pressure is force over area, isn't it? So the force is 0.6 and the area is 1.2 into 10 raised to the power minus 3. And the answer that you end up getting is 500 pascals. Remember, upthrust, let me write it down, is a force which is caused due to pressure difference. Now to calculate the density of the liquid, please try to relate it with the previous part, which is pressure difference is equals to rho g into height difference. Now you calculated the pressure difference between the top and the bottom surface, and that pressure difference turned out to be 500 pascals, which is equals to, now please try to imagine this, that in this height of 5.8 centimeters, the liquid density was rho. So we're basically using this amount of liquid to generate this pressure difference. The pressure difference was between the top and the bottom surface, right? So between the top and the bottom surface, what was the height of the liquid? 5.8 centimeters. So 500 is equals to rho, which we have to find, times gravity, which is 9.81, times height difference, which is 5.8, 10 raised to power minus 2. And that answer is 880 kilograms per meter cube. The liquid in B is replaced by another liquid of greater density. State the effect, if any, of this change on the upthrust acting on the cylinder. Now, please try to understand. There's a great simple relationship. Density will cause pressure difference will cause upthrust. So if you increase the density, it'll increase the pressure difference, so your upthrust will increase, right? Now, if your upthrust will increase, which means this force has become more, do you still need this force to be 5.6? No, you don't, because upthrust plus 5.6 equals 6.2, which is the weight, isn't it? So if your upthrust increases, you would want this force to decrease because the weight is constant. Now, if this force in the spring decreases, what will happen to the extension in the spring? Force is proportional to extension. If the force in the spring decreases, the extension will also decrease. So this is going to decrease. The principle of superposition states that when two or more waves meet at a point, then the resultant displacement is equal to the algebraic sum of the individual displacements. Now you have a microwave transmitter. So microwave transmitter is going to emit a signal in this direction, which is going to reflect at the surface of the metal or the metal plate. And you will have two waves traveling in opposite directions, which will meet or overlap, and a stationary wave will be produced between these 2 points. So what is the function of the metal plate? It reflects the wave. Microwaves have a wavelength of 0.04. A stationary wave is formed. Calculate the frequency in gigahertz. Well, you know microwave is a part of the electromagnetic spectrum. So I will be using C is equals to F lambda. C is the speed of light. 3 into 10 to the power 8 is equals to frequency into 0.04. Now when you will divide 3 by 0.04, you will get 7.5 into 10 raised to the power 9, which is actually 7.5 gigahertz. So the detector is placed at a point where you detect a minima or an intensity minimum, and they say now you move it towards the plate. So let's say you move it from here to here until you hear the next minimum. So here you hear a minimum, then you hear a maximum, and then you hear a minimum again. So remember, the distance between two minimas is half of a wavelength, lambda by 2. So you had the wavelength, which was 0.04 divided by 2, which is 0.02. Determine the number of intensity maximas that are detected by the receiver as it moves from X to a position that is 9.1 centimeters away from X. Now, you want to calculate the number of intensity maximas. And the distance that they're giving you from X to that point, so let's say this is X, and this is that point, which is 9.1 centimeters away. Right? Now, each minima, you started with a minima here. Each minima is coming after what distance? After 0.02 meters, right? So if I ask you what is the number of minimas, you would simply say 9.1 centimeters, which is 9.1 into 10 to the minus 2, divided by 0.02. And the answer is 4.55. Those are your minimas. So this means that this is n is equal to 0. Then you have a minima at n is equal to 1. Then you have another minima at n is equals to 2. Then you have another minima at n is equals to 3. And then you have another minima at n is equals to 4. Now, the reason why this is not going all the way to the end is because all the way till the end, it's 4.55, as you can see. So the fourth minima would be slightly before 9.1. So how many maximas do you have? Let's count. You have a maxima here, that is maxima. Then you have your second maximum. Then you have your third. Then you have your fourth. And here you go, you have your fifth. So how many maximas do you have? You have 5 maximas. Do you understand? Because if you take the total length, you'll get 4.55. But minimas have to be in whole numbers. So that means the fourth minima was short of 9.1 centimeters. 9.1 centimeters is your total length. 9.1 centimeters is this total length. The last minima would not be here, it would be here because we have 0.5. And if I go exactly halfway ahead of a minima, which is 0.5, what do I get? A maxima. So I've got 5 maximas. They're asking you for the maximums. The answer is 5. State Kirchhoff's second law. The sum of EMFs in a closed loop is equal to the sum of potential differences in that loop. A battery has EMF 4 volts and internal resistance 0.35 ohms. The battery is connected to a uniform resistance wire XY and resistance R. Wire XY has resistance 0.90 ohms. So from here till here, you have a resistance of 0.9 ohms. And the potential difference across XY is 1.8 volts. So the voltage drop in this part, the resistance wire, is 1.8 volts. And you know the resistance. So you can calculate the current using V is equals to IR. 1.8. 1.8 is only in this part of the wire, which has a resistance of 0.9. So current into 0.9, and the current therefore turns out to be 2 amperes. Please try to understand. A lot of you make this mistake. You've put 1.8 as the voltage. You end up putting the resistance as the total resistance of the circuit. Why? Where is this voltage? V is equal to IR. The voltage and the resistance must have a relationship. Remember this. If you are using the EMF, which is 4, then you take the resistance of the whole circuit. Only when you're using the EMF. Let me write that down over here. EMF is I total R total. Please refer to my electricity videos if you've forgotten this. Comes from V is equals to IR. If instead of V you put EMF, now EMF is of the cell and the cell is of the whole circuit, not a particular part. So therefore, if you're using EMF, you take the entire resistance of the circuit. But over here, they have not given you R, so I cannot use 4 by any means. You cannot divide 4 by 0.35, for God's sake. Why? Because 4 is just not giving the voltage to 0.35, it's giving voltage to the whole circuit. It's the cell. So if you want to use 4, then you have to take 0.35 R and this wire. Unfortunately, we don't have R, so you cannot use 4 at all. That's why they gave you the voltage difference, potential difference across XY, and they gave you the resistance of only XY, which is 0.9, and you got 2.0 ampere. No need to write ampere again because ampere is already written. Next, the number of free electrons that pass in the battery in a time of 45 seconds. You have the current. You know current is rate of flow of charge, isn't it? And that means current is equals to N into E over T. Now the current is 2, the time is 45, and the value of E, this is given to you in the data booklet, this is 1.6 into 10 raised to the power minus 19. So divided by that, and you get the number of free electrons. The number of free electrons turn out to be 5.6 into 10 raised to the power 20. Now, part C says a cell of EMF 1.2 volt is now connected to the circuit in B as shown. And this is the example of null method. Whenever you have 2 cells across a resistance wire, you should go to electricity part 7, part 8, part 9 and have a look to understand the concept here. Well, anyway, the connection at P is moved along the wire XY. The galvanometer reading is 0. This is called the null method. I've discussed it in my videos. Make sure you watch them. Electricity part 6, 7, 8, 9. When the distance XP is 0.3 meters. So when this distance is 0.3 meters, this galvanometer reading over here is 0. That means that there is no current. Calculate the total length of the wire XY. Now that is so interesting. So let me start with a little background here. You all know that V is equals to IR. You all know that the resistance of a wire is given by the formula rho L over A. So you know V is equals to I into rho L over A, correct? Now if the current, resistivity and area are constant, then you know that the voltage is proportional to the length, right? So in the previous part, you were given the fact that this voltage XY is 1.8 volts. So 1.8 volts represent a length XY of the wire because voltage and length have a direct relationship. Here you're given that this length is 0.3 and this galvanometer reading is 0 ampere. What does that mean? That there is no current in this part of the circuit. Now, why is there no current in this part of the circuit? Try to understand. The reason is very simple, because the voltage between X and P, if I connect a voltmeter over here, what is that voltmeter reading if there is no current? Although this cell is giving you a voltage of 1.2, but there's no current coming out of the cell. The reason is this voltmeter reading is also 1.2 volts. There's no potential difference. The voltage in this part and the voltage of the cell are the same. They're equal. You need a potential difference for current to flow. Now, because there's no current, I can safely say that the voltage in this part and the EMF of the cell is the same. If you don't understand this, you need to understand the theory behind it. Please go to the videos, part 7, part 8, part 9, finding the EMF of an unknown cell, and you'll understand the theory behind it, okay? But it's actually very easy. That the voltage in this part, if that matches the EMF of the cell, there will be no current in this part. That's why it's called the null method. So I can say that 1.2 volts represent this length of wire, which is 0.3 meters. I have a question. If I change the length, it's not 0.3, it's 0.5. Now will there be a current? Absolutely. Because this voltage will not be 1.2. It'll be more than 1.2. Now there will be a potential difference. But yeah, if you take this point from here and bring it here, let's say this reading becomes 1.5 volts. This is still 1.2. So 1.5 minus 1.2 gives you 0.3. There will be a current. So you have to ask yourself, what is so special about the galvanometer reading being 0? The answer is very simple, that the voltage between these 2 points and the EMF of the cell are the same. Now all you have to do is you have to cross multiply like this. So 1.8 into 0.3 is equals to 1.2 into length xy. So length xy will be 1.8 into 0.3 divided by 1.2. So therefore this length turns out to be 0.45 meters. Now in the last part, they're saying that the fixed resistor is replaced by a different fixed resistor of resistance greater than R. So the first thing is that if you increase the resistance over here, what is going to happen to this voltage XY? That's the first question that I have for you. The second question I have for you is what is going to happen to the current that is coming in this wire? So the first answer is voltage XY will decrease. Why will voltage XY decrease? Because V is equals to IR, right? We're talking of XY, so you have to talk of resistance XY. Resistance XY, the length, the cross-sectional area, that hasn't changed. However, because the current in the wire has decreased, voltage XY has decreased, right? That means that voltage XP has also decreased. And if you ask me why has voltage XP decreased, it's very simple. Use the formula IR. Resistance XP is the same because you haven't changed the resistivity, you haven't changed this length, you haven't changed this area. So the resistance is the same. The current in the wire has gone down. Therefore, voltage XP is also reduced. So voltage XP is now less. Okay. So voltage XP, this voltage is now, let's say 1.1 volt instead of 1.2. It was 1.2 when this reading was 0. Now the question is, where should you move this galvanometer? should you move it to this side or to that side so that this galvanometer reading is again 0? Please recall, I told you that the voltage is proportional to the length. Now remember that the length is always being measured from the fixed end. So this is the length that they're talking about. And they're measuring the length from end X. So this is the length. Now they're talking about the fact whether this length should be increased or whether this length should be decreased so that this galvanometer reading is 0 again. Abhi, problem kya hai? What's the problem right now? This is 1.2 and this is 1.1, so this is not 0. You want this reading to go to 1.2 so that this reading can be made 0 again. So, if voltage is proportional to length, I want 1.1 to go back to 1.2, so I should increase the length, right? By increasing the length, what do I mean? You should move the wire this way. So point P should be moved here. So the length should increase. It should move away from X so that the galvanometer can become 0 again. Why would that become 0? Listen to this. When you will move the wire to this side, you will have a greater length, right? And when you have a greater length, this voltage Vxp will also be more. Naturally, when Vxp will become 1.2 again, when this will be 1.2, this will be 1.2, this will be 0. So this is the question that they were asking. State and explain the change, if any, that must be made to the position of P on wire XY so that the galvanometer reading is 0. So first thing is you need to underline this, that the resistance R has increased, hence the current in the circuit has decreased. Current in the circuit has decreased. That's the first step. The second step is you need to mention, that means that the voltage XY has decreased and voltage XP has decreased. And I gave you the logic over here. Then you would say that since voltage XP is proportional to length, the length must be increased so that voltage XP becomes equal to 1.2 volts again. Bear in mind that when this reading will go to 1.2, the cell is remaining at 1.2. No matter whether you put the jockey here or there, the cell's voltage is going to remain 1.2. So you have to bring XP back to 1.2. Right now it's 1.1. You have to bring it back to 1.2. So how do you do that? By changing the length, by increasing the length, the voltage will increase. If you decrease the length, the voltage will decrease. And always remember that length is always being measured from the fixed terminal. How do you know which is the fixed terminal? Please remember, galvanometer's circuit is what determines the fixed terminal. So you see, the galvanometer is connected to one side, which is a movable contact, and the other side is connected to this terminal. So this end is your fixed end. So the fixed end. So the length is always being measured from the fixed end. So the answer to that question is simple, that the length is increased by moving it towards Y. State the core composition of a proton, that is up, up, down. The core composition of a neutron is up, down, down. That of an alpha particle is basically a helium nucleus, that's helium-4. So you have, that's helium-4, 2 actually. So that means you've got 2 protons and 2 neutrons. So that means that you have 2. Proton is up, up, down, plus you've got 2 neutrons, that's 2, up, down, down. So let's just add them. So that's like 2 into 2, that's like 4 ups plus 2 down. This is from here. And then when you multiply this 2 inside, you get 2 ups plus 4 down. Because you see, these are 2 downs, right? 2 into 2 gives you 4. This is 1 up, 1 into 2 gives you 2. Similarly, these are 2 ups, so 2 into 2 gives you 4. And that's 1 down, so 2 into 1 gives you 2 downs. So add them, you've got 6 ups and 6 downs. So 6 up, 6 down. State what must be inferred from the observation that most alpha particles pass through the foil. Well, the answer to that is that the atom is majorly vacant. The observation that some alpha particles are scattered through angles greater than 90 degrees, that there is a very dense positive charge in the nucleus. Hence, alpha particles get repelled. And you must mention here that the majority of the mass is concentrated in the nucleus. A proton and an alpha particle are moving in the same uniform over acceleration of the alpha particle. That's represented like this, A P over A alpha. Now, you know that both the alpha particle and the proton would experience a force in the electric field, and that force would be equivalent to ma. You know that the force is Q times E, charge into electric field strength, which is equals to ma. Now, if I ask you about the proton, you'll say P and P. So acceleration of the proton would be QP over E into MP. And similarly, acceleration of the alpha particle would be charge on the alpha particle divided by the electric field strength into the mass of the alpha particle. Now, because they're asking you AP over A alpha, so basically you have to divide these two equations. You have to divide this equation by this equation. So if I say what is AP over A alpha equal to, you will say QP over MP into E divided by Q alpha over E into M alpha. So QP over MP into E into M alpha over Q alpha. Now you know that the electric field strength is the same, so it cancels out. So basically you have to put the charge of the proton. The charge of the proton is 1.6 into 10 raised to the power negative 19 times the mass of the alpha particle is 4 times 1.66 into 10 raised to the power minus 27. This value and this value, they're given to you in the data booklet. So 1E is 1.6 into 10 raised to the power minus 19 coulombs. 1U, unified mass constant, is 1.66 into 10 raised to the power minus 27 kg. So let's say, for example, you're talking of helium nucleus, helium-4 They ask you, what is the mass? You will simply say it's 4U. That is why I wrote it as 4 into 1.6 into 10 to the minus 27. If they ask you, what is the charge on the helium nucleus? So the charge will be 2 times of E because it has got 2 protons. And what is the fundamental charge? That is 1.6 into 10 to the minus 19. So let's go back. Instead of QP, I just put the charge of a proton. Mass of alpha, that was 4U. 4 was the mass number into unified mass constant. So I get this divided by, this whole thing divided by MP, the mass of a proton, which is 1.66 into 10 raised to the power minus 27, into the charge of alpha. The charge of alpha is 2 times of E, which is 2 times 1.6 into 10 raised to the power minus 19. If you're wondering, can I simply write this as E? Sure, why not? Let's do it like that. This is E. Can I write 4 into 1.66 into 10 to the power minus 27 as 4U? Be my guest. Absolutely. Can I write 1.66 into 10 to the minus 27 as U? Of course. Can I write 2 into 1.6 into 10 to the minus 19 as 2 times of E? Absolutely. So just simplify. U will get cancelled. E will get cancelled. You'll get 4 over 2. The answer is 2.